143, page 2, and you're asking about these probability models. So when we're talking about the probability of anything, it's always what we want to see happen, that's the numerator, divided by all the possible things that can happen, right? And we use this fancy thing, sample space, and we call it big S, for all the possible outcomes. And then we can have a probability for a certain outcome. So if I said, what's the probability of flipping a coin once? Well, we only have a sample space of 2, right? Heads or tails. The probability of heads is 1 out of 2. It's 1/2. All right, so these are just, again, going over these definitions, that in any probability model, we need to have the sample space, and then we can talk about the probability of any set of outcomes. And it gets more complicated than just having, 2 heads or tails. We can start to put together many things, right? It says a sample space can be very simple or complex. Toss a coin once, there's only 2 possible outcomes. We can write the sample space as big S, sample space is heads or tails. When a Gallup poll draws a random sample of 1,523 adults, the sample space is all the possible sets of responses, right, of 235 million adults, right? And so that's an extremely large sample space. And we could never write out all the possibilities, right? You couldn't say S and write out all the different possible things that could happen when you're drawing that many. All right, so often when you're asked to find sample space and define it, you're going to not have too many things. All right, now let's this definition event. An event is any collection of outcomes of some chance process. So an event is a subset of the sample spaces. So the event is like the heads would be the event in the tails. And we usually talk about these as big A, B, C is just we look at. So if A is any event, we would write the probability as the probability of A. It's just how you read it. In a dice rolling example, suppose we define the event A as a sum that is 5. What is the probability of A, right? That's all that's saying. Remember, mathematicians are kind of lazy, so they don't want to put it out. So to get a sum of A to the event A, right, a sum of 5 is the event, we could have 1, 4, 2, 3, 3, 2, 4, 1. That's how we could get 5. Now we have to think about, well, what's the sample space? What are all the possibilities, right? The denominator is all the different things. Well, if I roll 2 dice, I get 36 different things happening, right? And if I said, what's the probability of getting this 5? Well, 4 out of 36, to which we can simplify. Right, now consider some other event, right? And now we're saying, well, B, the event B is being defined as the sum is not 5, right? So if there's 4 out of 36 ways to make 5, to not make 5, there has to be the opposite of that, right? 1 minus that, or 32 out of 36. And we can do this, the probability of event B is the sum isn't 5, the probability is not A. All of that is just noticing that if we have 36 different things happening, right? 4 of which are getting a 5, and the rest, which is 32, are not getting a 5, then we can say the probability of A plus the probability of equals 1, right? The total different events that can happen has to equal what's possible, right? So there's 36 different things possible, and we have to say account for, if there's 4 plus 32 is 36, so we're accounting for it. All right, let's think of another event. Let's call it C. In C, we're saying the event C is when these 2 dice add up to 6. So there's 1, 2, 3, 4, 5 ways the event adds to 6, or 5 out of 36, and we can't simplify that. Right? What is the probability we get a sum of a 5 or a 6? Probability of a 5 or a 6, just saying that that's A or C. Well, that's going to be the probability of getting a 5, which was 4 out of 36, and then probability of getting a 6 was 5 out of 36, so one or the other would be 9 out of 36. So that's how we're adding it. All right, now what's the difference? What's the difference between a probability model and a simulation? Well, a model is looking at all the possible outcomes. A simulation is actually doing it. And as we do more and more trials in a simulation, we're going to approach a probability model. But if you were just to roll some dice, there's not to say that you roll the dice 36 times, you're going to get exactly 4. That's the sum of 5, right? As you roll the dice more and more times, then you're likely to approach that value. But you're not going to get it just rolling it once. So that's the difference between a simulation and a model. All right, I hope that's far enough. If it's not, tell me and I'll go further.